Greetings and salutations, everybody. This is Jacob. How's everybody doing? I hope you're having a splendid day or evening, depending on where you're at. And boy, do I have an interesting puzzle for all of you. It's a probability puzzle concerning matchboxes. This one's gonna tickle your gray matter a little bit, just like it did mine. Oh, yes. Better believe it. Those pesky synapses are going to be firing on all cylinders with this problem. All right, enough with the introductions. Let's get right into it, shall we? A cave-dwelling prophet is carrying in his pockets 2 matchboxes, one in his right pocket and one in his left. Each time he needs a match to light up one of his torches, he is equally likely to take it from either pocket. So he goes through the matchboxes until he's discovered that one of them has emptied. Both boxes contain initially 50 matches. The question is, at the moment the prophet opens the empty box, what is the probability that the other box contains exactly 15 matches? Pause the video if you'd like to give this problem a try. And when you're ready, smash that play button. Okay, so how do we go about solving this problem? Suppose we take a match from the left box. Since the prophet is equally likely to snatch matches from either side, then the probability of that is 0.5, correct? Now, let's take one more match. This time, suppose it's from the right side. So taking a match from that side is also 0.5. But what is the combined probability of taking from the left and then from the right? Because these are what we call independent events, and we just multiply the probabilities. 0.5 times 0.5 equals 0.25, correct? Is that the correct probability? No, not quite, not yet. It would be the correct probability if the order in which we picked the matches mattered, but the order doesn't matter. It doesn't matter if we picked the right one first or the left one. So we multiply the 0.25 with the combinations of both pickings, which is 2. So now we get 0.5, which is correct. So let's take this a bit further. Let's say we pick a match from the left box. So we have 0.5 times 0.5 times 0.5. And the number of combinations is 3. So now we get 0.375. Notice this is actually the binomial distribution. The formula of which is f of x equals n over x times p to the power of x times 1 minus p to the power of n minus x. And this describes the probability of a Bernoulli success-failure experiment being performed n times, where x is the number of successes. A success in this context is when we pick a match from the box that is empty. The trials are also independent, as we said before. N over x is a formula for the combinations, which is n factorial over x factorial times n minus x factorial. Okay, so now here comes the tricky part of the problem. Your first instinct might be to just plug x equals 50 in the formula and call it a day. But no, there's still some intricacies here. In order to discover that the box is empty, we have to choose it 51 times, not 50 times. 50 times is when it actually empties, but we haven't realized it yet. But we don't plug in 51 in the combinations formula, we plug in 50. Now why is that, you ask? Now remember we said order doesn't matter, right? Well, in the last pick, order does matter. We can't, for example, realize the box is empty, then go pick a match from the other box. Makes sense? So the very last pick is fixed. So the actual number of combinations when we go from 50 to 51 doesn't increase. So we just plug in 50 in this part of the equation, and then in the next part we plug in 51, since we picked that box 51 times, correct? And then we have 0.5 to the power of 35 in the last part, since we're left with 15 matches in the remaining box. And we do the calculations, and we end up with 0.0115, which is 1.15% probability of the other box having 15 matches. And that's your answer. Yeah, it seems indeed like an intuitive answer, if you ask me. Yeah, that was a really good problem. I'm really glad I stumbled upon it in my problem-hunting escapades today. I have many more like these in the pipeline. Mind-bending problems that are just chomping at the bit of getting unleashed. Oh yes, some real monster problems. I'm saving those for when I reach 1 million subscribers, and then I'll release them. I'm kidding, of course. But you know the drill. Just hit those buttons. It helped me immensely so that I can continue uploading these amazing problems, some of which I've made. That's the whole point of this channel, to challenge myself to make my own problems. The geometry one, I made that one. And of course, I'll continue posting problems I haven't made. Most of the problems you see on this channel will be of the latter category. So yeah, I'm going off on a tangent here. I'll just end it here. So I'll see you guys in the next video. Bye-bye.